Okay, now we're starting with number 16 from the mock exam. So we want to know, when is this function going to be concave up and increasing? So we're looking for concave up and increasing. Okay, so let's find when it's increasing first. That's the first derivative. And you should get that. And then we're going to set that equal to 0. Divide everything by 6. Factor out an x. And we will get that x equals 0 and x equals 2. So here's our wiggle graph. We're going to put 0 and 2 in there, and we're going to substitute into f prime. So you're going to take a value to the left of 0 and substitute into f prime, and you should get negative. And then the next line should be positive and negative. So the question is asking, when is it increasing? And it's increasing right here from 0 to 2. So that's our interval when it's increasing from 0 to 2. Okay, now we have to figure out, when is this concave up? Okay, so concavity, that's all about the second derivative. So that's our second derivative. We're going to set that equal to 0. Divide everything by 12. And we get that x equals 1. So we make a wiggle graph, and we're going to substitute into the second derivative. So you're going to take a value to the left of 1, such as 0 or negative 1, and you're going to put it into the second derivative, and you will get positive. And then to the right of 1, you'll get negative. So we're looking for when is it going to be concave up, and that would be here. So that would be from negative infinity until it gets to 1. So the question is, what interval would include both of these things? So they both have 0 in them, they both have 1 in them, but that's it. So that was choice A. Okay, this is number 17, and this is to do with velocity, which we are actually learning this week. So if you're watching this now, you can save this until after you've learned it, or you can watch it now, and then maybe you'll understand a little more when we do it. That's completely up to you. But we're trying to find out when when the velocity of the particle is 0. So you're given x of t, and that represents the original function, and velocity is just the first derivative. So this is going to be a product rule. So it's the first times the derivative of the second plus the second times the derivative of the first. So the derivative of e to the something is e to that something times the derivative of the something. Okay, so how do we find out when a particle, the velocity of the particle is 0? You take the velocity and you set it equal to 0. So I'm also going to simplify a little bit here. I'm going to take this negative and put it over here. And I'm going to put the 12 and the e in front and put the trig function at the end. Okay, so I want to know when this is equal to 0. This is a non-calculator question. So hopefully you notice that there are some things we can factor out. We can factor out a 12 and an e to the negative t. Okay, so we'll set them each equal to 0. Okay, so when does 12e to the negative t equal 0? Well, you can divide both sides by 12. Okay, there is no number that you could put in for t that is going to make this equal to 0. So this is never true. Okay, let's look at the right side. So if you bring sine of t over, when is cosine equal to sine? That is pi over 4. We've talked about this, or 45 degrees. We've spoken about the only angle where both sine and cosine are equal to each other is at 45 degrees, and that is choice A. Okay, here's number 18. This is what we just learned, the second fundamental theorem of calculus. Now, you might say it doesn't look that way because there's no d dx in front. However, we're trying to find f prime of x. So if I add a prime on the left side, don't I have to do that on the right side? And look what I've just done. It is now the second fundamental theorem of calculus. Okay, and now we can just take this x and put it wherever we see a t. And that was choice D. Now you might be saying, don't I need to take the antiderivative of this? No. This is the second fundamental theorem of calculus, which means that you just have to put the x in wherever you see a t. Okay, here is number 19, and this is a linear approximation. So we want the tangent line, so we're going to start here. And we were given that x equals pi over 2, so we can put that in. But we were not given y. So how can we figure out what y is? Well, we can substitute it into here, and we'll figure out what y is. Because y is just equal to 2 cosine pi over 2 plus 1. Okay, so they're testing you on your unit circle. So what is, because you won't have a calculator. So what is cosine of pi over 2? Well, pi over 2 is located right here. That's the coordinates of that point is 0, 1. The x-coordinate is cosine, the y-coordinate is sine. So cosine of pi over 2 is 0. So y equals 2 times 0 plus 1. Therefore, y equals 1. And now I can substitute it into here. Okay, and now all I need is m. So that's just going to be the slope. So let's make this. Okay, so my slope is going to be 2. The derivative of cosine x is negative sine x. The derivative of 1 is 0. So my slope is just negative 2 sine x. And we need to find the slope at pi over 2. Okay, and from the unit circle that I just drew before, sine of pi over 2 is equal to 1, which gives me negative 2 for m. Okay, so this is the slope of the tangent line, and now we're being asked to approximate f of 1.5 using the tangent line. So that means where there's an x, we're going to put 1.5. Okay, and that's not a choice, but we're going to simplify. So we're going to distribute that negative 2. And when we distribute it to the next one, we'll get a positive, and you just have a pi left over because the 2's will cancel. And theirs is all in the form of y equals, so we're going to have to bring that 1 over. And that was a choice. That was choice C. Okay, and finally, here's number 20. And remember, you will not have a calculator, so you have to be able to graph this picture by yourself. And this is what it would look like. Okay, so if you don't know what this looks like, so you would do it the old-fashioned way. You'll make yourself an XY chart. You'll try 0, you try 1, 2, 3, etc. Get the XY coordinates and just plot it, and you'll start to see what happens, and then hopefully it will start to look familiar. Okay, so A is saying the limit as x approaches 2, and this is 2 right here, is equal to 1/2. Okay, that is false because the limit coming from the right side is not the same as the limit coming from the left side, and therefore A is out. Okay, B, there is a removable discontinuity at x equals 2. That is false because the removable discontinuity looks something like this, where there's no jump involved like that. Okay, so B is out. Okay, C says there's a jump discontinuity, and that's what I had just said, so C is still in the running. And D says there's a discontinuity due to a vertical asymptote. Okay, that would be false, because a vertical asymptote would be if it looks something like this. And therefore, C is the winner.